This lesson corresponds to Roman numeral 4B in the Honors Chemistry Unit 6 packet. We're going to be talking now about covalent compounds. In ionic, you had to cross the charges. Covalent is actually a lot more simple. We're going to use prefixes when writing covalent compounds. The prefix for one you've probably seen before is mono, like carbon monoxide. Two we've seen is di, like dihydrogen monoxide. Remember there were two hydrogens. Three should be pretty easy if you think about anything that has three, like a triangle or a tricycle. Four is a little bit hard sometimes. It's tetra. If you've ever played the game Tetris, the four boxed figures, tetra goes with that. 5 and 6 are pretty common terms for geometry and shapes, like the pentagon and the hexagon. You might have even studied 7, the heptagon. 8 is a pretty common one, so like an 8-legged creature or an 8-sided figure, the octopus. And for 9, we use nona. So these prefixes just go in front of the name of an element in a covalent compound. A couple things that I want to note as you're thinking about writing these. First of all, you will never have to use never use mono on the first word. And another thing that I want you to think about is the second word always ends in the "ide" ending, just like in an ionic compound, how if it was a nonmetal it ended in "ide." Okay, so let's look at some examples. We've got carbon monoxide. So again, we never have to use mono on that first word, so if it's carbon, it's just C. Monoxide, mono is 1, that means 1 oxygen, CO. What do you think the difference is between carbon monoxide and carbon dioxide? Well, di means 2, so instead of using CO, you use CO2. Let's look at the next one, dihydrogen monoxide. Dihydrogen means 2 hydrogens, so H2, and then monoxide means 1 oxygen, so O. Try the last one. So trichlorine is Cl3, because tri is 3, and then pentoxide would be O5, because pent is 5. And it's just that simple for covalent compounds. Another thing I want to point out for covalent compounds is you do not have any crossing. So I'm going to put that on here. No crossing and no reducing. Keep that in mind when you're doing covalent compounds. There's no crossing and there is no reducing.